This video shows details of tests conducted to assess the resistance to vibration loosening of some common fasteners. The tests were completed on a test machine, commonly known as a Junker's machine, or more formally, a fastener transverse vibration test machine. In the 1960s, Gerhard Junker developed a theory as to why fasteners self-loosen under vibratory loading. Other researchers have subsequently verified his findings. Junker found that transverse dynamic loads generate a far more severe condition for self-loosening than dynamic axial loads. Any transverse movement which occurs between the joint plates will quickly loosen plain non-locking fasteners. To test his theory, Junker developed a test machine whose basic principles are shown here. An electric motor drives a cam that displaces a moving plate by a predefined amount. Such movement results in a loosening action causing a loss of clamp force. By measuring this loss of clamp force during the test, the performance of different fastener systems can be compared. The arrangement of the test equipment consists of an electrical motor driving a cam connected to the motor by drive belts. The cam is designed to displace the top section of the machine by a set amount. The cam is connected to a top sliding part of the machine that sits on needle roller bearings. A load cell is located under the sliding part of the machine to allow the clamp force present in the fastener to be continuously measured. The machine can test bolts or nuts depending upon the way the fastener is inserted into the machine and the adapters used. In this first test, a bolt is placed in the machine and tightened using a plain washer and plain standard nut. The clamp force, or bolt preload as it is sometimes called, is measured and recorded by a computer that can be connected to the test equipment. Once the test is started, standard nuts quickly self-loosen. Speeding up the video, the self-loosening of standard nuts during this test becomes obvious. As the loosening progresses and the nut rotates, the force present in the bolt reduces. The reduction of the force present in the bolt throughout the duration of the test can be plotted on a graph. The results, when indicated on a preload decay graph, can highlight characteristics of particular locking mechanisms. In a matter of seconds, the clamp force can be reduced to zero. Tests completed with certain locking devices have shown them to be ineffective in resisting self-loosening. Helical spring washers are commonly used across a wide range of industries. Tests completed indicate these locking devices to be ineffective in resisting high levels of vibration as produced by a Junker test. Helical spring washers can be shown to come loose as fast as plain washers. Bolt Science is an independent engineering organisation which is focused on solving issues relating to bolting and threaded fasteners. This includes theoretical and test investigations on bolt and joint failures, tightening and related problems and issues. Our experience extends across a wide range of industries. If you have a bolting problem, why not discuss it with us and see if we can help?